Example 6, determine whether the integral from 0 to pi over 2 secant x dx converges or diverges. Solution: note that the given integral is improper because the limit as x approaches open pi over 2 close to the power negative secant x equals infinity. Using part A of definition 3 and formula 14 from the table of integrals, we have the integral from 0 to pi over 2 secant x dx equals the limit as t approaches open pi over 2 close to the power negative. The integral from 0 to t of secant x dx equals the limit as t approaches pi over 2 to the power negative. The natural log of secant x plus tangent x, the natural log of the absolute value of secant x plus tangent x on the interval from 0 to t equals the limit as t approaches open pi over 2 close to the power negative. An open bracket, the natural log of open secant t plus tangent t close minus the natural log of 1 close bracket equals infinity, because secant t approaches infinity, and as tangent t approaches infinity, t approaches open pi over 2 close to the power negative, or from the direction negative. Thus, the given improper integral is divergent. Example 7, evaluate the integral from 0 to 3 of dx over x minus 1 if possible. Solution: observe that the line x equals 1 is the vertical asymptote of the integrand, since it occurs in the middle of the interval open bracket open bracket 0 and 3 close bracket. We must use part C of definition 3 with c equals 1. The integral from 0 to 3 of dx over x minus 1 equals the integral from 0 to 1 of dx over x minus 1 plus the integral from 1 to 3 of dx over x minus 1, where the integral from 0 to 1 of dx over x minus 1 equals the limit as t approaches 1 to the power negative of the integral from 0 to t of dx over x minus 1 equals the limit as t approaches infinity, the limit as t approaches 1 to the power negative, the natural log of the absolute value of x minus 1 on the interval from 0 to t. The limit as t approaches 1 to the power negative of open the natural log of the absolute value of t minus 1 minus the natural log of the absolute value of negative 1 equals the limit as t approaches 1 to the power negative of the natural log of open 1 minus t close equals negative infinity. Because 1 minus t approaches 0 to the power positive as t approaches 1 to the power negative, thus the integral from 0 to 1 dx over open x minus 1 close is divergent. This implies that the integral from 0 to 3 of dx over open x minus 1 close is divergent. Open bracket, we do not need to evaluate the integral from 1 to 3 of dx over open x minus 1 close bracket. Warning: if we had not noticed the asymptote x equals 1 in example 7 and had instead confused the integral with an ordinary integral, then we might have made the following erroneous calculation. The integral from 0 to 3 of dx over x minus 1 equals the natural log of the absolute value of x minus 1 on the interval from 0 to 3 equals the natural log of 2 minus the natural log of 1 equals the natural log of 2. This is wrong because the integral is improper and must be calculated in terms of limits. From now on, whenever you meet the symbol, the integral from a to b of f of x dx, you must decide by looking at the function f on open bracket a and b close bracket, whether it's an ordinary definite integral or an improper integral.